Okay, so take it as a learning opportunity here. Paul continually bends and unbends his flexible plastic ruler. It looks like this. Choose a letter that best completes the statement. The aspect of measuring that is affected in this case would be accuracy, because it's things that can affect it is damaged or the improper use can affect, right? So one of these two is happening here, so it would be accuracy. And can we turn off that music? Whose music is that? That Ranji? The precision wouldn't be affected because the spacing in between is still accurate, still stays the same. Uncertainty is based on precision. Tolerance, not really what we would want to use it for, okay? So accuracy. Next, Rick is measuring the volume of liquid in the cylinder below. State the precision of cylinder A. So what you would want to do here is either just estimates, like I think it's going up by 50 every time, right? If you figure that out, then you're good. Like that's it. Precision is 50 mLs. If you didn't, right, or you could do high minus low. So you grab, let's say 300 minus 200, let's say, and you divide that by the number of gaps. There'd be 2 gaps between those two numbers. So it'd be 100 divided by 2, which is 50. So regardless of how you do it, it's 50 mLs, and so you get 1 mark for that. Precision for cylinder B, this one is actually fairly straightforward. It's just 100. So the smallest increment, that's what precision is. It's 100 for this one. Justify which one is more precise. You would have to say cylinder A, smaller precision. It doesn't ask you to justify, so if you just said cylinder A, you get the marks. However, the province on this one would say, let's say you made a mistake and you put down a 200 up here. We would want you to state cylinder B as the more precise, right? So it's based on your answers. Okay. Next, this one leads over to the next page. Didn't mean to do it, but it happened. So Marco needs to mix water with his eco-friendly herbicide concentrate for his garden. If too little water is added to the herbicide, it will kill his vegetables. If too much is added, the herbicide will not be effective. Okay. State the uncertainty of the measurement if Marco uses container A. Watch this, it's asking for uncertainty, but we know better, right? We will start with precision, then find the uncertainty. So what is this? You know it's going up by 2 liters at a time. I don't think you needed to do the high minus low on this one, but if you did, no big deal. So 2 divided by 2, it's just 1 liter, right? Plus or minus 1 liter, not necessary. If you have 1 liter, we're in business, okay? So what is this page out of? 1, 2, 3, 4, 5 so far. Backside. Still the same question, but it's a B part to it. Marco needs to add 12 liters of water to the herbicide using container B. Calculate the total uncertainty of the measurements if Marco uses the container 12 times. Okay, so here we have to be careful. Let's figure out our precision first and foremost. What is it? Have you figured it out? It's 0.2 liters. That's the precision. Therefore, my uncertainty would be 0.2 divided by 2, and that's 0.1 of a liter. This is the uncertainty of this container. I would give you a mark already. If you have that, I give you a mark already. Okay, but here's where if you're using this thing 12 times, like you're scooping out or you're adding, then the total uncertainty will be 12 times 0.1. okay, which is 1.2 liters. This gives you the second mark here, you multiplying it by 12. You know what? Whatever you got up here, you got the same answer, we're good. It can be done in many ways. So if you get this number, we're good. I'm going to see how you did it later. Interested to see how you do. If you got this wrong, like let's say you stated your uncertainty to be 0.2, I would expect you to go 12 times 0.2, right? So you'd be 2.4. But then you would lose the mark up here for not stating the correct uncertainty. That's how it goes, guys. Lots of easy, well, I shouldn't say easy, right? But they're actually not that time consuming, right? So you gotta be careful. The yard is being fenced in on 3 sides as shown below. Calculate the maximum length of fencing required using the measurement and uncertainties below. I want to tell you this. Usually, every measurement will have an uncertainty attached to it. Every measurement. Every measurement can give you a max or a min. Okay, every single one. We would add the uncertainty to get the highest and the lowest. We would subtract. So what you could do is, for every single measurement, you get the max. Like you add, I'm going to state the max here, the max there, and then just add those up. That's one way of doing it. I will do it differently. So I will use this space here. I'll say 28 feet plus or minus 0.7. Another 28 feet plus or minus 0.7. Then it's 55 feet plus or minus 0.6. I will add that all up, right? Because I'm combining the length to know how much fencing I need. I have my key here somewhere. There you go. If you add this up, you get 2.0 feet. And if you add up all your measurements here, you get 111 feet. So this would be like combined length of this whole thing, but we could be off by 2 feet. If I see you do this, you already get a mark. If you came up with 111 plus or minus 2 feet, you get 1 mark already. To get the max combined length, you just go 111 plus 2. So it's 113 feet. You get another mark for that step right there. The minimum would be 111 minus 2, subtract. So every single measurement technically gives you a max and a min. That's what you could have done. Just add these two, put it down. Add these two, put it down. Add these, put it down, and then just add those individual numbers. You would have arrived with 113 as well. If that's what you did, full marks. Okay, full marks. Next, the tolerance of a measurement is 0.007 meters. The nominal value, which is the maximum, is this. Okay. Which one is an acceptable measurement? Let me help you out here. You know that the max, this is the max, you know that that's 15.084 meters. You're told, you're given that. Okay. How would you get your min out of that? We know that this is tolerance. There's a 0.007. Like this tolerance is the difference between the max and the min, right? Because remember, to get tolerance, we subtract max and min. So this is the difference. So what we do is we go minus 0.007. So we go this minus 0.007 to get my lowest value. And if you didn't know today when you looked at this, then just now kind of be like, oh, okay, right? Tolerance is always in between. It's always in between. So this gives you 15.077 of a meter. So this is your max, this is your min. Okay? Now, we want to know which one of these measurements is acceptable, knowing that these are our parameters. We have to be on or in between. Is this one good to go? This one is 9.1, like you're actually going to be above here somewhere, not good. 15.078, it's just above this one. It's actually here. This one is good. This one actually meets the criteria. This one is too big, and this one is too small. Okay, so this is the only one that applies in this particular case. So everything in here is okay, and everything outside is not okay. Frustrating, I know, but keep learning. Add it to your notes and in your brain and on your study sheet. Just keep going. Okay. Okay. Hold on. I'll come by in a bit. So what are we at in the back here? Hold on. We've got 2 marks and another 2 that's 4 and another 1 that's 5. So the back is worth 5 as well. 5 and 5, we're at 10 total. So put it at the top here with your name and last name. And we're going to do round 2. Yeah, I'll come and see you. Different focus, this one. This one has a bit more tolerance on it. So, do you mind having these Actually, maybe let's do this first. Can you face down? Have your ACs facing down, pass them forward. And we'll collect before we hand out. Main culprit here. So just write down whatever you haven't filled in. And it's still a good gauge for you to see where you're at, okay? What's the difference between uncertainty and tolerance? Uncertainty is caused by the limitation of device. Okay, that's what uncertainty is there for. It's caused by the limitation of the device. Whereas tolerance, this is set by the industry, right? It is the range of acceptable values. Okay, that's what it also is. So if you have something like that, you're good to go. Define tolerance using your own words. Okay, so here we go one more time. Tolerance, the range of acceptable values, right? You can say that, right, if there's a max and a min, that tolerance is in between, okay? Tolerance is the difference between them. So everything in here is okay, and here it's discard, right? Discard, discard. So everything outside of that range or the tolerance is not acceptable. All right? In each case, state the nominal. So the nominal is just a big number up front. The max is just adding these two together, and yes, they are very small numbers. You end up with this if you add them up. And minimum, you subtract, but you find out that it's the same. Okay? It's the same as your nominal, but that's okay. Right? Over here, the nominal would be 4.3 inches. And the max is you just add these up. So the max would be 0.048 inches. The minimum is when you subtract, right? So you get 0.018. not meters. I'm on the wrong page, right? That's inches. Wrong units. Okay, so you add to get this, okay, and you subtract to get that. Next, given the tolerance for a pipe that is this, state the tolerance in the three other forms. So the maximum is this plus that, so that'd be 355.75. Minimum would be this minus that, that is 355.25. Tolerance is these two subtracted, right? So that'd be 0.50 basically. And nominal is just that big number up front, okay? So that's your nominal. So now we can do it in the other format. So we're going to go 355.75 centimeters, stack it on top of 355.25. Okay, so this should be that. That give you a mark. Then the other one is max, whatever you determine to be the max. That's 355.75 centimeters plus 0 minus, what's my tolerance? 0.50 centimeters. And then the last one is minimum, which is 355.25 minus 0 plus 0.50 centimeters. Don't forget your units. Okay. Last one here on this page. You might have to come back to this tomorrow to finish it completely. But you're sewing together two pieces. Watch this. This is the trick. You go precision, it's 0.1. Uncertainty is 0.05. You just divide that in half. The next piece you're sewing onto this one, precision is the exact same, uncertainty is the exact same. So nothing there. I would give you a mark if I see something like that already. Now I'm going to add it up, but I'm not going to worry about my precision. I'm just going to add up the measurements. That's 114.4 centimeters plus or minus, when you add this up, you get 0.1 centimeters. So this is the combined length with the combined uncertainty, folks. Okay, that's what you just did there. Another mark for that. A mark for you and a mark for you. You just take the marks. Anyways, and then max and min can be determined from this. So when it says total combined, you need to first combine both, then get your max. This plus that gives you 114.5 centimeters, and the lowest you can possibly have is 114.3 centimeters because you subtract, okay? This is what I'm after here. That would be your third mark right there. Fun stuff, eh? Yep. We're good? Back side. Okay. Explain which beaker is more precise. You can't just guess, okay, if you want the full marks. The precision here is, what is it? 30, 40, 50, 60, it's 10 milliliters. The precision here is 50 at a time. It's from marking to marking, okay, guys? So this is 50 mLs, okay? Beaker A is more precise. Some students have in the past on the exam say, I think it's A because the markings are closer together. That's a no-no, right? They want to see like, what is it? What is the increment? Okay? So this one wins because it's smaller increment. Next, this is an exam mark right here. This is an exam question, copy paste. I don't know which year. That's all they did, 1 mark. What's the nominal you think? 3 numbers to choose from. It's this one. Can I say something? It's always the big number up front. That is for sure your nominal. Right? 25 centimeters. And there's no halfers here. You can't like get half a mark. It's either 1 or nothing. Last one. If you read this, I want you to work on accuracy is off. Accuracy is off. You make a scenario. You either say improper use of measurement, proper use of measuring tape, or you can say the tape was damaged. Obviously, I would like you to elaborate a bit more. That you have two choices when you want to talk about why someone's measurement might be off. That's it. That's all. Okay, hold on. I'm gonna. The homework is gonna be a take-home AC. So the homework is you need to have it done and bring it back tomorrow. It has to be done. Okay, so you potentially